Good morning, sir. My name is Ko Singing, and I will present for the Computer Security Group Project. My group members are Lim Ai Sing, Kelvin Su, Kieu Ka Hui, and Xiani Ming. Problem statement. The article Privacy Preserving Authentications, Authorizations and Key Agreement Scheme for Wireless Sensor Networks in 5G Integrated Internet of Things by So-Yun and Ted Yang is used in this project, and this is the network model of the author's proposed solutions. In the articles, authors have stated that big integrations of wireless sensor networks and 5G networks in the IoT has increased the vulnerabilities of security attacks due to the increasing of connectivities. Therefore, the authors suggest the proposed scheme, ECC-based anonymous authentications, authorizations, and key agreement as shown here. It is a scheme that enhanced from a recent proposed scheme known as anonymous three-factor authentications and access control scheme for real-time applications in wireless sensor network. Authors have found that the existing scheme is prone to user collusion attacks on the user data availabilities and sensor node anonymity attack on the data confidentiality of the wireless sensor network sensor node while it is transmitting message. System setup integrity. The asymmetric keys exchange works to ensure integrity is found on the system setup and user registrations. First, through creating a secure channel in Authentications and Authorization Server (AAS). AAS will produce private and public key which is and a one-way secure hash function hash to secure all the messages sent from user or mobile device user. Then, to secure the integrity of communications between AAS and gateways, AAS will create a shared secret keys, and for each available sensor node's communication in the gateways, AAS will create another shared secret keys. User registration integrity. When user wish to send a request message to register into AAS, users input ID, password, biometrics, and a secret random number will be hashed and sent through the AAS. Then, AAS will proceed to produce an authorization link to user and store the user temporary ID into its own memories. User will store this DI to achieve mutual authentication with AAS. These mutual authentications and one-way hashing will prevent fabrication during message transmissions, as it will terminate any transmission if modifications occurs. AAK phase confidential. Confidential is found during the transmission in the AKK phase. The user real identity is not transmitted during all phases, so the identity cannot be obtained directly from the message, while the temporal identity is protected by the random value xi and one-time share key between AAS and user, and ID is not possible to derive from the temporal identity because ID is masked with A, and A is protected by biometrics, which is only known to user. Furthermore, session key is generated between user and gateway to protect further communication with the secret random numbers. This session key is used only once for current sessions and is independent of other sessions key owns to its random numbers. AKK phase non-repudiation. The asymmetric keys exchange works to ensure non-repudiations is found on authentications, authorizations, and key agreement AAK phase. In AAK phase, there are 4 timestamps are used in transmitted message between user, gateway, and AAS. Before the message is transmitted, a timestamp is generated. When the message is received, the validity of the timestamps must be checked so that if the validity is not established, ASS can immediately terminate the sessions. This approach can help avoid replay attacks where an attacker impersonates a varied user and resends the captured message to user. That's all from me. Thank you.